In this video, I will explain you what is compound microscope and its magnification. Okay. Now, in the case of compound microscope, the only difference as compared to simple microscope is it is having two lenses. One is near object and this is called as objective, and the other one is near eye, so this is called as eyepiece. Okay, now we are going to see from here, and this is the object which we are going to see, and that is creating an image here. So I will explain this in detail. Okay, now this is a convex lens and this is also a convex lens. Just compare, this is having a small aperture and this is having a large aperture. Now this is a small object I have kept here. Now this object would create an image here. So one ray going parallel to principal axis that will pass through focus and would go in this direction. We need one more ray to intersect with this to create an image. So another ray from here that is going in this direction, that is through optic center, and this ray and this ray would intersect. So ray 1 and ray 2 intersect at this point, and that would create an enlarged image at here. Okay, now this has created an enlarged image here, but this is not highly magnified. Okay, maybe 1 times or 2 times or maybe 10 times, but we need 100 and 100 times magnification, a larger magnification. So what will I do? I know that an image is created here. Now I will keep this image in between focus and optic center of a different convex lens. So I have a different convex lens here which is eyepiece. Now this image is kept in between. So automatically the moment the image is being formed here, that is formed in between focus and optic center. So what will happen? Now from here there would be 2 rays or multiple rays. So I am going to consider 2 rays. One is the one which is passing through focus, and after refraction that would go parallel to principal axis. This is my principal axis. This would go in this direction. So this is one ray. I need one more ray. So I will consider the next ray as passing through optic center, and that would go in this direction. So this would never intersect in this direction. So I would extend these 2 rays so that I have seen that they intersect at here. Now this is a magnified image of this, and also this is a magnified image of this. So what is the actual magnification? The final image, that is A double dash B double dash divided by the actual object AB. This is magnified twice, in between these 2 points and in between these 2 points. So A double dash, this I am going to multiply and divide with A dash B dash. So A double dash B. Okay, so this is equation number 1. So equation number 1 on multiplication and division with A dash B dash into A dash B dash. So just multiply with this. It's simply 1. Just cancel, this will become 1. So M is equal to A double dash B double dash. Now multiply with A dash B dash divided by AB into A dash B dash. This is the change I have made. I brought A dash B dash in the numerator and also in the denominator so that there won't be any change. So I am going to simplify this as A double dash B double dash divided by A dash B dash into A dash B dash divided by AB. See, these 2 I have taken as a one term, A double dash B double dash divided by A dash B dash. Now these 2 I have taken as one term, A dash B dash divided by AB. Now what is A double dash B double dash divided by A dash B dash? This divided by this. So that magnification is done by this lens, that is magnification of eyepiece, it is ME. Now A dash B dash divided by AB, that magnification is done by objective. So that is magnification of objective. So this is the actual magnification, and this is very, very important. Now next thing is magnification. I have to further simplify this. So magnification of objective Okay, keep objective as MO itself, and ME we know because this one is simply a simple microscope. Just go back and search simple microscope in the lectures. You would see that in simple microscope I am keeping my object in between focus and optic center so that I am having an enlarged image here. So this is simply a simple microscope, this part. So I can substitute the equation of simple microscope in the case of eyepiece. So into 1 plus D by Fe. So this is one condition, and I have one more condition. This is equal to MO into 1 plus, sorry, instead of 1 plus D by Fe, only D by Fe. This is a relaxed condition. This previously I also have told you we will have two equations. One is relaxed condition. Now other thing is at D. Now the difference is, now this is creating an image, right? If the image is in between F and O, you can use this equation. So here image, or I can say that A dash B dash is in between F and C. Now if A dash B dash is at focal length of eyepiece at Fe, then I have to use this equation. So either this or this. If A dash B dash is here as shown in the picture, then this equation. If A dash B dash is here, I have to use this equation. Okay. Now one more thing, I have to get the value of MO. So magnification is nothing but, so I will use this as the general equation. Okay, both of them are same. So this is one equation and this is another equation. So this equation I am going to take as a general equation. M is equal to magnification of objective, that is VO divided by UO, standard equation, into 1 plus D by Fe. See, magnification we have learned, right? V by U. So I have just substituted VO by UO. Now UO can be approximated as focal length of objective. This is a just approximation. Now UO, what is UO? That is the distance from objective lens to the image created by objective. That is this is the image created, and this length, okay, this would be preferred in such a way that when this become closer to here, we will have a highest enlarged image. So just visualize that if this is somewhere here, then we will have a much enlarged image here. Or simply I can say that we would always prefer to be this distance as the total distance in between these two lens. So when this image moves closer to this lens, we are having the highest enlargement, and that is how we are going to set our microscope. So this distance, that is distance in between the image created by object, that is A dash B dash, with respect to the objective lens, can be assumed as the total distance in between objective and eyepiece, or not, that is nothing but length of the microscope. So I am taking an approximation. VO is equal to length of the L, which is length of microscope, and one more approximation, UO is equal to focal length of objective, focal length of objective. So in these two conditions, I am going to do the substitution here. FO divided by, VO is L, right? So L divided by UO is FO into 1 plus D by Fe. This is the magnification equation, actual equation. This is one condition. In this condition, A dash B dash should be in between F and C. If it is at F, then that is for the relaxed condition. What would be the equation for relaxed condition? Instead of 1 plus D by Fe, M is equal to L by Fo into D by Fe, or I can say LD divided by FOFE. This is the condition of this is the equation for magnification in the relaxed view condition, or when the image is at D, then the equation is magnification is equal to this one, L by FO into 1 plus D by FE. Either this equation or this equation. I have told you the conditions when we are using this equation number 1 and equation number 2. Accordingly, you can substitute the value. Okay, thank you.